I'm excited to introduce our speaker, Giulia Silvestro. She's a highly skilled data engineer, and today she will talk to us about Python-powered data engineering and how to build a modern end-to-end data stack. In the session, she will walk us through the process of building a sales analytics pipeline, and you'll leave with a practical blueprint you can adapt immediately and a set of tools and techniques to help your team ship data projects without burning the cake. Please join me in giving a warm welcome to Giulia Silvestro.
Hello everyone, I'm Giulia Silvestro, and today I'll share with you a practical blueprint for building an end-to-end data pipeline using Python and the tools and approaches that I've learned and used throughout my career. But who am I? I'm Giulia Silvestro, I'm a data engineer at Agile Lab, and I've been a data engineer for the last 4 years. I am also an active member of Python Catania, and I love both sharing knowledge and learning from others in the tech community. And this is what inspired this talk. So let's start from the reality. So which is that the data teams are usually facing huge pressure as they need to deliver insight fast, but they are stuck juggling complex tools, growing data volumes, and scalability issues. So the result is a lot of disconnected system and eventually a lot of frustration. So this is where Python can actually help, because it offers a rich ecosystem of best-in-class tools, and also it is production ready and can handle end-to-end workflow, as we will see in this talk, from ingestion to visualization. To make this concrete, I'll walk you through an e-commerce analytics example, from collecting raw transactions to delivering interactive dashboards. So we'll work with multiple data sources, complex, for example, AI endpoints, database files, and complex transformations. And at the end, we'll reach the point of building an interactive dashboard. Here's the roadmap. We'll go step by step through ingestion, storage, transformation, then orchestration, and also visualization. And each step will use Python tools and open source tools when possible. So let's start from the first step, which is ingestion. So we'll need to ingest data from different sources, which could be REST APIs, for example, Stripe data, Shopify, or Salesforce data. Data from databases, for example, Postgres, MySQL databases, and files such as CSV, JSON, Excel. And we may also need to scrape web pages, so build scrapers that get, for example, competitor pricing or products review. So how can we collect all this data in a simple, unified way? And Python makes this very straightforward, because for each source type, we have a straightforward stable library. So for example, for REST API, we have requests. For reading database data, there are a lot of different drivers connectors for all the different databases. To read data files, we'll have pandas or pyarrow for Parquet files or polars. And to read data from web pages, we can build scrapers using requests and Beautiful Soup to parse HTML text files. Once the data is ingested, we need a place to store it efficiently. And for small scale projects, you might use SQLite, but or for medium, you could use Postgres, SQL Server. For large scale, you could use Snowflake, BigQuery, and this is the traditional approach, so using building a data warehouse. But what if we need something that's fast but also simple enough to run locally? Powerful for production, but also not too expensive. And my proposal is to use File Storage and DuckDB. So let's talk about DuckDB. DuckDB is an embedded analytics database, and you can think about it as SQL-like simplicity, PostgreSQL features, and Snowflake's speed. But why use it for a pipeline? Because it can directly read Parquet files from object storage. So we could store data as, for example, Parquet files on a blob storage, and then read it using DuckDB's engine. And this helps us because it runs in process, so we don't need a database server. And the queries are 10 or 100 times faster than Pandas. And this is because it uses columnar vectorized query execution engine. And it has a native integration with Pandas data frames, and it's perfect for datasets from 1 to 100 gigabytes. We'll also structure data following the medallion architecture, so bronze, silver, and gold levels to keep things organized and traceable. Where bronze means means a layer of data that is ingested as is, so no particular transformations. Silver, which is the intermediate layer, where we'll store clean, typed, and standardized data, and then the marks are aggregated and business-ready tables for analytics and reporting. Now that we have assessed how we will organize and store our data, we can focus on how to transform the raw ingested data in a clean and organized and insightful data. So, my advice is to start simple with using pure DuckDB SQL. So no servers, no clusters or external services to set up. It's just one file with all the transformation and only one engine. And it is very fast, so the speed is incredible. The vectorized execution makes it very fast, and especially on Parquet files and CSV files. But when you need to scale up as your project grows, I strongly suggest to move to using DBT, because it brings more structure and control to the entire process. DBT is a Python command line interface. It is open source, and it is a transformation framework. And I suggest to use it because it gives modularity and refactorability. So each model, which is a stage of the transformation, can be referenced, and you can create dependency between different models. And DBT automatically builds a DAG and executes query in the correct order. It also allows to have incremental processing, so which is native, and also merge strategy. So it's easy to keep a large table updated without full reloads. It also has a built-in testing framework for data quality, so you can implement automatically schema tests, so unique null relationships, etc. And tests are run automatically with every build. It auto generates documentation, for example, lineage graphs, and column description, model relationships, and it is perfectly integrated also with Pandas and Polars. So models can be written also in Python, but preferably you should use SQL. But for complex, for example, statistical operation, you can use Python. So now that we got all the ingestion and transformation process in order, we need to focus on how to make it run. Because right now it only runs when we manually execute Python scripts. But in production we need automation. So we will need an orchestrator, because your first approach could be manual runs, cron jobs, or time-triggered lambdas, AWS lambdas, but we need something that's better and suitable for this task. So for example, we will need precise scheduling, so daily, hourly, or event-triggered schedule. But we'll also need task dependency. So for example, transformation should run only if ingestion succeeds, etc. We should also be able to monitor the retries. So, for example, if one of the processes fails, we'll need a retry strategy, and also we should need real-time monitoring. So we could see the status of the pipeline, the logs, the metrics, etc. But also we must be able to easily rerun historical data, and also we should be able to run independent tasks simultaneously without losing the task dependencies. So we'll need an orchestrator. My suggestion is to use Daxter, which is written in Python. It is designed for developers and data engineers, and it is it's easy to define pipelines using simple and modular Python functions. So no really heavy YML or user interfaces required. It is very easy to deploy because it works with Docker, Kubernetes setups. It has a simple client, command line interface, and also an easy configuration system. And it has a seamless integration with dbt. So it would be perfect in this example of this project, because it makes dbt projects fully orchestrated and observable all in one platform. And finally, we have built our all this great data infrastructure, but now we need to make it accessible for business users. For example, let's paint a picture of a stakeholders needs. For example, sales managers might need to know which products are trending in this month. Marketing teams may need to know what's the return on investment by channel. The CEO might need to see revenue trends, and to serve all these users, we need a dashboard that's interactive, so with filters by date, product, channel, and it needs to be also fast, so queries must be returned in milliseconds. It should also be self-service, so business users shouldn't need to ask the data team for answers to their questions, and critically, it needs to be easy to build because we are data engineers and not front-end developers. And there are different tools that enable us to build dashboards easily, but my suggestion is Streamlit. There are other tools, for example, Power BI, Tableau, but they are very expensive. So in Streamlit instead is pure Python, so you don't have to use know HTML, CSS, JavaScript, or know how to use external services. But the whole dashboard is built in Python. It is reactive, so all the graphs and widgets also update. It has a built-in caching system, so queries run only once. And it's very easy to set up and also easy to deploy, because you could use the Streamlined Community Cloud, which is free, or it's easy to containerize and then use Cloud Run, ECS, app services, Kubernetes, etc. to deploy it. Here we can see an example. So we can see how simple it is to define a bar chart, for example. So we don't need JavaScript, complicated framework, but it's just Python. So we can write our query. In this case, it's written in pandas, but we could also use, we should use DuckDB. So my idea is to use Streamlit and then read the data using DuckDB, so using its power and its powerful engine for analytics. And then we can simply define the graph and the whole dashboard only using Python. Now, let's quickly recap everything we've covered today. So this graph, this diagram shows how our complete end-to-end architecture works. So Dagster orchestrates the ingestion scripts, which read data from different sources and write them in the in a file storage, for example, blob storage. Then DBT. The Dagster orchestrates also the transformations defined in DBT using DuckDB as an engine, and it uses the medallion architecture and writes the data of the different stages. And then Streamlit, always using DuckDB, reads from the data marks produced by the pipeline and produces its dashboard. And that's it. Thank you so much for your attention. I hope this blueprint gives you confidence to build your own Python-powered data pipelines. And I'd love to answer any of your questions. Alternative, you can reach me at my email, or you can add me on LinkedIn if you want to chat about data engineering or anything else. Thank you for your attention.
Thank you, Giulia, for the clear and insightful walkthrough. Your demonstration has given us a practical and approachable way for building scalable pipelines. We truly appreciate your expertise and the clarity you brought into such a complex topic. Thank you so much for sharing your knowledge with us.